Hi geometry class, and welcome to a new week. Today is Monday, January 18th, and we will be looking at lesson 5.4. 257 is the page number in your book. And there will be a little bit of terminology review that we're going to do, but then we're going to be talking about a new theorem and then looking at a review of the different postulates and theorems that we've learned over the last week. Again, I don't think this is difficult. If you're thinking, you should be able to grasp this, and it is one more building block in all of the different things that we're learning in order to be able to prove our proofs. So to begin, I want to start with a review of terminology. So we're going to look at, if you look at the title, Hypotenuse Leg. And so we want to review, if you take a look at your book on page 257, there's a nice little skateboard ramp there. I don't know how many of you skateboard, but that should be kind of opening your brain up a little bit. Those skateboard ramps are most likely right triangles or pretty close to it. And you can see the little diagram of how it's built. But we want to review the terminology because we're going to be using this language in this lesson. So the hypotenuse, let's remember that the hypotenuse is what's right across from our right angle. In this case, the angle is C. That's our right angle, 90 degrees. The hypotenuse is right across from us, from it. Then the two legs are the lines right beside it, or the sides that are right beside it. So if you have trouble remembering that, you could print this out and put it in your index cards. You could also just make a mental note of it. It's not that difficult. The hypotenuse is right across from the right triangle. Okay, so then let's take a look at the theorem that has to do with this. Again, on page 257, here is the little blue box, so to speak, the hypotenuse leg congruence theorem. And in order to make it a little bit easier for you to write, you can just use HL. I'll know what that means. That's what they indicate here. So if you're solving a proof and you put HL, that is totally fine. So here are the words. You know how they put it in pictures and in words for us, which is a great thing. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles have to be congruent. So there's no choice. So here, let's take a look at it now in our pictures. If the hypotenuse, so I'm following the hypotenuse right here, and the leg, here's a leg, of a right triangle, it's right because it's got the symbol in there, are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. So then we would know that this is equal to this, or congruent, this is equal to this. Therefore, A, B, and D, E would also be congruent. So pretty easy, not difficult to understand, and we call this one the HL, or the hypotenuse leg congruence theorem. But that's a lot of words to have to say. Okay, so let's take a look at proving. I'm skipping over example 1. I think you can probably read through that and understand it. But let's look at example number 2, and we're going to work through that. And so I have provided the top bit of information for you. It says use the diagram to prove that triangle PRQ, that's this right here, PRQ, is congruent to PRS. Now they give us some information, and that's always so important, but we also want to look at our diagram and see if there's any other information that maybe they haven't given us. And later on, they will give you less and less in words and probably more things in the diagram. So we note that PR is perpendicular to SQ. Okay. That can tell us a number of things. it most likely would tell us that angle PRQ is a right triangle, just like the other one was. My dog is right here by my side, giving me a little bit of lip. So you might hear her talking. So let's move on. Okay, they also tell us that PQ is congruent to PS. So we figure that out. We also know that we have two right triangles here, some from the words and some from just observing the diagram. All right, so just a reminder on how you are supposed to write these proofs. You create two columns, statements, reasons, or you could also put proofs for here. Now I've moved to the next one. Let me make sure that's where I wanted to go. Okay, so they have listed their PR is perpendicular to SQ. I think it's helpful to not list all the given right up front. I think you put it where it should logically come in your proof. So that would be one little tidbit of instruction as you work through this. So see that they did list this first one, it's given, and then they tell us, they move on to make another assumption, and we already talked about that a little bit. PRQ and PRS are right angles. Partly from what we've been given, but partly because we know that perpendicular lines form right angles. So we're going to use what we know. This was a definition, I believe, but you could look back in your index cards to see if it was a definition, postulate, or theorem, and then you would write that in there. So we know that perpendicular lines form right angles. And then we're going to go on to the next one. And we're going to make the next logical step. PRQ, PRS are right triangles. And that just merely comes from the definition of a right triangle. We know that right triangles are going to have those perpendicular lines. We also know that they're going to be 90 degrees. And we have all this information, so all we really need to do is put down here definition of a right triangle. That just kind of encompasses all the information that we know about right triangles. Okay, so then we keep moving along. And remember, my point that I want to prove, I always list that last. I just list it at the bottom so that I kind of know what I'm working towards, kind of my roadmap. So let's remind ourselves, PRQ is congruent with PRS. So we got to get there. And so we've just told ourselves that PRQ and PRS are right triangles. That's great, but we don't know if they're congruent. And that's the piece that we kind of need to move toward next, proving that. All right, then we find out so then we maybe are going to start working on the lines, because remember, we probably are going to use the HL that we just learned. So we need to know that some legs and the hypotenuse are congruent, right? So we go back up here to given information, and they have told us that PQ is congruent to PS. We'll mark that if we haven't already. And we have that down here now. PQ is congruent to PS. That was given. Pretty easy. All right. Now, the next statement that they make is that PR is congruent to PR. And we hit this one last week a little bit, that reflexive property. That's going to get used a lot when triangles are smushed together like this. So let me just put that in your mind. Always be thinking about reflexive property, because chances are you have an overlap line, and that's what we have here with PR. So PR is congruent to PR, reflexive property. Well, now I have this guy, PQ, congruent to PS, and now I have PR congruent to PR. I have two right triangles, so let's see where we go next. Okay, now we can say that PRQ and PRS are congruent because the angle opposite, there's the can't even say it, hypotenuse. Here's the hypotenuse. Those are equal, congruent. Then one of the legs, we don't know about this one, but this leg is congruent. Therefore, we have the hypotenuse leg congruence theorem working to prove this proof. So I hope this helps you a little bit with the logic of working through the proofs. We're going to just keep practicing these all year. One of the things that this does, it helps you to think through logical arguments for a lot more than geometry. So be thinking, and as you get further in science and needing to work steps in your research, this will help you. Okay, let's review then the 5 triangle congruence postulates and theorems. Remember, we have side, 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 means they're all equal. Side, angle, side, where you have 2 sides and the angle in between them is equal. Angle, side, angle, where you have 2 angles but the side between them are congruent. AAS, angle, angle, side, angle, angle, side. And then finally, the one that we learned today, the hypotenuse leg, where the hypotenuse, the angle or the straight line across from the right angle, and one of the legs are congruent. Obviously, you know your 90-degree angle is also congruent. So it's almost like the angle side. Could you use that instead? Probably, but I would use the HL. So that is all for this lesson. Hopefully that was fairly easy, straight to the point. Hypotenuse leg, congruence theorem, and that's where the hypotenuse, the one across from the right angle, and one of the legs are congruent. So if you have any questions, let me know. You will be doing some homework that includes a couple of proofs. I didn't include all the examples on the PowerPoint because then it could get a little long, but I would encourage you to look through example number 4 if you're having difficulty with the proof. I think there maybe is only 1 or 2 that you're doing for homework. And then if you have any questions on Wednesday, make sure to jot those down and I will be sure to answer them.